Have you ever heard of a molecule that can help your body fight aging, protect your brain, and even boost your workout performance all at once? It's not a miracle supplement, it's something your body already makes naturally, L-Carnosine. In this video, we'll explore what L-Carnosine is, how it works inside your body, what the latest science says, and whether taking supplements actually makes a difference. L-Carnosine is a dipeptide, a small compound made of two amino acids, beta-alanine and L-histidine. You can think of it as a cellular bodyguard. It's found in large amounts in your muscles, heart, and brain, where it helps keep cells balanced, energized, and protected from stress. It fights oxidation, glycation, and acid buildup, three key processes that contribute to aging and cellular fatigue. L-Carnosine was first discovered in 1900 by the Russian scientist Vladimir Gulevich. At first, researchers didn't understand its function. They just knew it was abundant in animal tissues. Decades later, studies revealed that animals with higher carnosine levels had greater muscle endurance and longer lifespans. By the 1990s, interest exploded. Researchers began studying carnosine's anti-aging, brain protective, and metabolic effects. Inside your cells, L-Carnosine acts like a quiet guardian, a molecule constantly working behind the scenes to keep your body balanced and protected. One of its most important roles is as an antioxidant. Every second, your cells face damage from unstable molecules called free radicals. Carnosine helps neutralize these reactive particles, shielding your DNA and proteins from oxidative stress, the same process that contributes to aging and many chronic conditions. But its protection doesn't stop there. Carnosine also has a remarkable anti-glycation ability. When sugars in your bloodstream bind to proteins, they form harmful compounds known as advanced glycation end products, or AGEs. These AGEs can stiffen tissues, damage skin elasticity, and accelerate cellular aging. Carnosine steps in early, binding to those sugars before they can do harm, almost like intercepting sparks before they start a fire. In your muscles, carnosine serves another purpose. It acts as a pH buffer. During intense exercise, lactic acid builds up, lowering pH and causing that familiar burning sensation. Carnosine helps counteract this acidity, keeping your muscles stable for longer and delaying fatigue. And finally, carnosine works as a metal chelator, binding to excess metals like copper and zinc that, when unregulated, can trigger oxidative reactions, particularly in the brain. All of these roles, antioxidant, anti-glycation, acid buffer, and metal balancer, come together to make carnosine one of the body's most versatile and intelligent natural protectors, quietly maintaining the delicate balance that keeps your cells healthy and resilient. The human body makes L-carnosine from beta-alanine and L-histidine using an enzyme called carnosine synthase. But there's a catch. Your ability to make carnosine depends mostly on beta-alanine availability. That's why beta-alanine supplements are often used to raise muscle carnosine levels. However, humans also produce an enzyme called carnosinase, which quickly breaks down carnosine in the blood. So not all the carnosine you take through food or supplements stays active for long. L-carnosine occurs naturally in animal-based foods, especially beef, chicken, fish, and pork. Plant-based foods, however, contain little to none, since plants don't produce it. This means vegetarians and vegans usually have lower carnosine levels, although the body can still make some from amino acids in the diet. There's no official carnosine deficiency, but low levels are linked to faster muscle fatigue, higher oxidative stress, and greater glycation, a driver of metabolic and age-related aging. In the vast world of health science, L-carnosine has quietly attracted interest as a molecule that, although small, may play outsized roles in aging, brain health, and metabolic regulation. Over the past decade, researchers have pieced together four major streams of evidence that illuminate its potential: combating glycation, neutralizing oxidative stress, protecting brain cells, and supporting metabolic and age-related health. First, consider glycation. When sugars attach to proteins, they create advanced glycation end products, or AGEs, molecules strongly associated with skin aging, stiffened blood vessels, and tissue damage. Studies show that carnosine acts as a glycation inhibitor. intercepting sugars and reducing the formation of AGEs in lab settings. For example, human skin explants treated with carnosine-infused cream showed significant reductions in AGE markers like CML and pentosidine. Second, on oxidative stress and inflammation, multiple meta-analyses indicate that carnosine or carnosine histidine-containing dipeptide supplements can lower markers like CRP, TNF-alpha, and malondialdehyde, a sign the body is under less oxidative assault. This suggests carnosine may help blunt the low-grade chronic stress that accumulates with time and contributes to many degenerative conditions. Third, brain and neurodegenerative health. Review articles point to carnosine's neuroprotective effects, such as reducing protein aggregation, supporting mitochondrial health, and even improving memory in small clinical trials. One randomized trial found that people taking a carnosine and serine combination for 3 months had better verbal episodic memory performance than placebo, along with changes in brain connectivity patterns. Finally, metabolic and age-related disease contexts. A systematic review of L-Carnosine in age-related diseases, diabetes, neurodegeneration, found statistically significant improvements in fasting blood sugar and in HbA1c in some trials. But as is common in such fields, the results are mixed, and many trials are small, short-term, or have methodological limitations. For example, one randomized controlled trial in autistic children found no significant change in AGEs following carnosine supplementation. So what can we conclude? The body of evidence suggests that carnosine is promising. It has multiple plausible mechanisms, and early human data show beneficial signals. But it is not yet a certainty. It is not a magic bullet. Larger, well-designed, long-term human trials are still needed to determine which populations, what doses, and which outcomes are reliably impacted. If you're considering carnosine supplements, here's what to know. Dosage, typically 500 to 1,000 milligrams once or twice a day. Absorption, limited by the carnosinase enzyme, meaning not all of it stays intact for long. Alternatives, many prefer beta-alanine, which raises carnosine naturally inside muscles. Generally safe, mild side effects like headache or nausea are rare. As always, talk to your doctor before starting any supplement, especially if you're managing a medical condition. L-carnosine might not be as famous as collagen or CoQ10, but it deserves attention. It's a powerful multi-role molecule, protecting your cells, supporting energy and brain health, and helping your body stay balanced against stress and time. While science continues to uncover its full potential, one thing is clear. Supporting your body's natural defenses is one of the smartest ways to invest in long-term health. Have you ever tried L-carnosine or beta-alanine supplements? Do you think oxidative stress like this could become part of future anti-aging strategies? Let us know in the comments below. This video is intended for informational and educational purposes only and should not replace professional medical advice. Always consult your healthcare provider before making any changes to your diet or supplement routine.